Hello, I'm Rita Maldonado and this is lab number 5. For this lab, I chose a code in C from the GitHub library and I completely translated it into assembly. This is the code and it's a bubble sorting algorithm which basically sorts an array of size n from smallest to largest by using bubble sorting, which makes the bigger numbers go up into the array and the smaller numbers sink. First, we would have our two variables, our size of the array, which is an integer number n, and then we would have our array of n numbers with numbers in no particular order. First, we would load our address from the first number of the array into A0, and then we would load the size of the array into A1 to then call our function bubble sort. Bubble sort saves the return address into the stack. It initializes our condition for the for loop, which is I to 0, and then it moves our address of the first element of the array into save register, and it subtracts 1 to n because the for loop will traverse n-1 iterations. So in the for loop we have the breaking condition, which is that it breaks when I is greater or equal to n-1. We would have our initialization of the bool variable not swapped to true. This variable checks if any changes have been made in one iteration of this for loop, and if they haven't, it would break the loop immediately and stopping the program because it means that the array has already been sorted. Then we would initialize the second condition for the second for loop, which is j to 0, and we would copy the address of A0 into another save register. Then we would have in the second for loop our breaking condition for the second for loop, which is that j is greater or equal to n-1. We would load the first number of the array into A0. We would look for the memory address of the next A1 in this case, and then we would load it into our A1. Then we would have a condition which is that if the first number is smaller or equal than the second number, it skips the call to swap, and if not, it swaps the two numbers out of place. If this happens, it would continue here into this line, which changes our bool variable to false. It moves the second number's address into A2, and it calls the function swap. This function just, saves the first number into the second number's memory address and the second number into the first number's memory address, and then it returns. It would return here, and it would jump to non-swap, which is basically where it would jump if it didn't have to change the two numbers. This only just adds 1 to the j, and it returns to the start of the second for loop again. Then when all the iterations have been done, this breaking point would be correct, so it would jump to the end for. Here it checks if the changes have been made to the array in this iteration of the for loop, of the first for loop. If they haven't been done, it would skip directly here, and this would end the program, and if not, it would just do another iteration of the for loop, and it would just repeat the same process over and over again. If either this happens or the I reaches n-1, it would just jump to the end for, where it loads the return address to jump to main, and it would return here, but it would end the program. Here you can see we have an array of 8 numbers, which are unsorted, and you can check that it works. Perfect. And then you can use any other numbers. I'm going to use these, for example, just to see that it does end before it should. I mean, it doesn't when it should, when it just and this program would just need 2 iterations of the first for loop for it to work. So here we would see that it does change in the first. Here it would call swap, so it would change the variable, and it changed positions, but in the second for loop, in the second time of this for loop, it doesn't change anything. So it would just return to the beginning, and it would just end. And this is the entire program.